Hi. One way in which I will be presenting content material in the course of Biology Honors is through these short video casts. That way there we can spend more quality time in the classroom doing hands-on activities and different labs. That does not mean that I will not be presenting any sort of content in class, nor does it mean that you're going to not ask any questions over the material, whether it's a chapter reference or whether it's anything that I might have said in this particular video lecture. Our first exposure to the course will be that of learning the different types of equipment that the biology class has to offer and how we're going to be measuring. So we often recognize it as the metric system, or the SI unit, the Standard International Units. Many times you have seen these when we watch the Olympics. For example, when you have the 100-meter dash or the 1600-meter swim, all of these are SI units. Often they're in length. Rarely do we have a measurement for volume or mass unless, for example, they're doing the weight lifting and, we put 1,000 kilograms in something, so some big dude's going to go ahead and lift it up. So the SI unit you've been exposed to if you've ever watched the Olympics. We will also be using these units in class. Common instruments that we're going to be using are called graduated cylinders. Notice they come in different sizes from relatively large to relatively small. Each will be appropriate for the amount of liquid that you want to measure. Graduated cylinders measure volume. And it could be the volume of water, it could be the volume of vinegar. Regardless, what you're going to do is try to always use the appropriate tool for the volume that you see. For example, if I'm going to be measuring 5 milliliters, I don't need this one that is going to measure 100. Rather, I need a smaller graduated cylinder in which the max capacity will be that of 10. So subsequently, one of the tasks that you will have this week as we do a couple of the activities is to use the appropriate piece of equipment for the task at hand. Another piece of equipment that we have in this class is called an electronic balance, or these called electronic balances. Whenever you do measure something, you want to make sure that you see zeros. Many of our balances will tear or zero out at 0.0. And so what we know then is that we are not measuring anything at this point, that there's nothing on there that gives any sort of mass. Notice I said mass and not weight. Often you're going to have a small cylinder, a round piece of paper that will be shiny on one end, and you could always add the various powders, whether it's salt or flour or maybe even calcium hydroxide. When you measure, make sure that after you add that disc of weigh paper, you zero it out or tear it, and then you'll be able to see the buttons on these more clearly in class. So remember, electronic balances measure the mass of something. Rulers. You've all seen rulers before, and often many of you are used to using this side of the ruler, or the English version. Rather, we're going to be using this, or the metric version, in class. Many rulers have letters right by the zero. In this case, it's called cm. That simply means that each one of these units that are divided up into the numerical things that you can see, each one is a centimeter. If this were, for example, a meter stick, I would see 100 of these centimeters to make up one of the meters. Or I can even look at the smaller units in that each dash line here represents 1 millimeter. So if I really counted up all of these little lines in between, I will notice that there are 10 millimeters for every 1 centimeter. So what I'm doing is I'm showing a relationship of the same distance but with different units. And so what we can look at in terms of rulers, they measure something called length, okay, or distance. So we will probably use this more frequently in terms of centimeters, millimeter conversion. So you'll be very, very apt at it once we get going with the different activities in class. Some common units that we will see: kilometer, centimeter, milligram, microliter. These are all ways to represent the volume, for example, or the mass. If you're going to use a large or have a very large weight, you want to use kilometer. But we're going to be looking at really small units in terms of the micro. As a matter of fact, these are going to become very familiar. Oh, this is a micro, this mu. It's a Greek letter for micro. If you can't use it on if you don't know how to put it on the computer, you can just put U. If you have a Macintosh, you can put Option M, and that'll give you that Greek symbol called micro. We're also going to use millis a lot in terms of the prefixes. So remember, all of these are prefixes. And these prefixes are often before the actual unit that we're going to be using. Okay, so you'll get more and more familiar with them. We really don't use this often in class, nor do we use that often in class, nor do we use that. So the other ones that we do use frequently are the ones that I have kept on here and not crossed out. That was a no-brainer. All right. So in general, this is kind of gives you an overview with respect to how to convert in terms of the mathematical relationship. Gram, meter, liter. These are all what we call our base unit. So in other words, everything is based in relative size to this base unit, or how many of these other prefixes are going to be used in order to make up a base unit. Let's say, for example, I want to look at how many millimeters are there in a meter. Well, I'm going to go ahead and I'm going to multiply that by 10, by 10, by 10. So I have multiplied by 1,000, so I said that 1 meter is the same as saying 1,000 millimeters. So that will give you a general idea in terms of how to use these conversions, or what is the mathematical relationship. Conversely, I would have gone and divided. If I had 1 millimeter, it would be 0.001 meter. So those are the ways that we can look at the mathematical relationship. This is kind of like a general term to kind of think about big, large, large, big. Remember, the actual size, the distance might be the same. It's the unit that will change. So here's some sample calculations here. Our conversions. If I want to know how many millimeters there are in 23 centimeters, I begin with what I know. I know I have 23 centimeters. I now know the relationship between the two, that there are 10 millimeters in every 1 centimeter. That simply means I'm going to cross out those units because they cancel each other out, and now I will multiply. So I now have 23 millimeters, and it's very important here that you always place the unit, so that way there that number has value, or at least something that we now can compare it to. So now I know that there are 230 millimeters for every 23 centimeters. Let's look down here. How many liters are in 500 milliliters? Well, again, I can cancel out these units because I show the relationship, and I want to know the liter. I can go ahead and say, okay, 1 0 canceled out, 1 0 canceled out. So I have 5 over 10 liters, or if I put that in a more appropriate scientific unit, 0.5 liters will be represented by every 500 milliliters. So it's really important where the decimal is in terms of your math, and it's really important what unit you are expressing so that people know what is actually being measured. Okay, let's try a couple more here. I want to know how many micrometers there are in 1.5 millimeter. Some people might want to go ahead and go from the micro back to the base, from the milli to the base to the micro. That's okay. Some of you might become quite acclimated and pretty much memorize this because we're going to use this particular function a lot, especially with our microscopes, hence the name there. So now I could go ahead and do my cancellation right here. And I now, oh, look at that. I'm going to have 3. I'm going to put additional here. This is, remember, representative of one of the zeros. So I'm going to have my multiplication. There's one of my zeros, 2 zeros. So I have 1,500 micrometers to every 1.5 millimeters. You can become even more fancy about this. Put that in scientific notation to omit a lot of the zeros. And each of these numbers is telling me the same length. That's the cool thing about the metric. It goes back and forth in terms of the unit will always give this sample length. Okay, last one, milligrams to grams. Okay, I'm going to cancel out. So I'm going to go from a large unit gram to a smaller unit. That means I'm going to need many, many more of these smaller units to make up that one big unit. So again, I'm going to start off with my 3, 6, 2. Here's one of my zeros, and here's 2 more of my zeros that I've multiplied with. And don't forget my unit. And so far I have 36,200 micrograms, that is going to be represented in 36.2 grams. We'll have a few more practice problems in class, and so my hope is that you can get away with using your computer and you'll have the sense of memorizing the multiplication or the division, i.e. moving the decimal left or right depending on whether you're multiplying or dividing. Okay, so hopefully you have some questions in class. If not, we'll just move along with our little lab activity that I have planned for you. All right? In the meantime, if you have any questions, make sure you ask.